All right, here's a practice problem. A circular rod is to support part of a storage shelf in a warehouse. As products are loaded and unloaded, the rod is subject to a tensile load that varies from 1,800 to 1,500 pounds. Specify a suitable shape, material, and dimensions. All right, so in this chapter, chapter 5, we're dealing with fluctuating stresses, okay? And we're going to look at equations on how to calculate sigma max, sigma min, and average, and we can use that to figure out some stuff, okay? So let me show you how to do this so you can get an idea. All right, given F equals 1,800 to 150 pounds, we're going to find the shape, okay, so area, material, and then dimensions. So we'll look for D. Okay, here's a sketch. And then we have tension. This is F. And let's get to the solution. Okay, so let's pick SAE 1040 cold drawn steel. Sigma T, your tensile strength, 552 megapascals, and SY, your yield strength, 490 megapascals. We can find these in the book. Okay, this is your tensile strength. This is your yield strength. Okay, and if you want to review, I added this little section here. It's a graph from this website. It talks about the yield point, right? And then here's your tensile up here. Okay, so anything past your yield, you'll start to get elongation, and then anything after your tensile strength will pretty much fracture. All right, what we're going to do first is we're going to find sigma D, which is called the design or allowable stress, using SY over N, which is like a safety, like a design factor. Okay, and we're going to pick 2. All right, anything over 2 is good. So sigma D equals 490 megapascals over 2. So sigma D becomes 245 megapascals. All right, and so we're going to call this, let me do this, just sigma from now on, and it's F over A. Okay, so the force over the area, because again we're looking at this section here or down here, right? So sigma is just F over A. And what we need to do is find the area for your maximum case and your minimum case, and then the bigger of those two we'll select. So let's go ahead and do this. So we got the max and the min. And so if we rearrange this equation, we have A equals what? F over sigma D. The max force was 1,800 pounds, so A equals 1,800 pounds divided by 1 pound. There is 4.45 newtons divided by 245 megapascals. Okay. Now make sure you convert the megapascals to pascals, and you get an area of 3.27 e to the minus 5 meters squared, or if you multiply this by 39.37 inches in 1 meter and you square this, the area becomes 0.051 inch squared. Let's look at the minimum. A equals 150 pounds times 4.5 newtons divided by 245 megapascals. In your area, you get 0.0042 inches squared after your calculation. Okay, so we're going to go with the larger area because we know it could hold more weight. All right, so let's go ahead and find D. And we know the area is pi d squared over 4. We're going to rearrange D equals area times 4 over pi times the square root. So 4 times 0.051 inch squared over pi, and your diameter becomes 1/4 of an inch. Okay, so now we picked my material. You could pick anything. We found A, and then we found the diameter. And now what I want to show you is how do we get a graph that shows sigma max, sigma min, and some parameters that we're going to use in the next problem. Okay, so we're now going to find sigma max based on this area that we selected now. Okay, all right. So we have 1,800 pounds divided by 0.051 inch squared. Okay, and sigma max becomes 35294 psi. Okay, we're going to find sigma min, 150 pounds over 0.051 inch squared, and sigma min becomes 2941 psi. We're going to look for the mean force, Fm, which is 1,800 pounds plus 150 pounds divided by 2. So this becomes 975 pounds. And then we can find our mean sigma, which is Fm over the area, 975 pounds divided by 0.051 inch squared. Sigma m becomes 19117 psi. And then we can find sigma a, which is just the stress amplitude. So sigma max minus sigma m. Sigma a equals 35294 minus 19117. Sigma a becomes 16177 psi. And then sometimes we like to look at the ratio of sigma min to sigma max, and this is called the stress ratio, and this is 2941 psi over 35294 psi, and you get this stress ratio to be 0.083. You're going to notice in the next problem, we deal with forces that change or move, okay, or different cases of your structure. And you need to find these values in order to calculate your design factor. Okay, so I just wanted to show you how they're found. And then we can graph this. So you'll see a graph. Oh, let me go up. Here is sigma m. And then it's going to go up and down and up and down and up, because it's 1,800 pounds to 150 pounds, 1,800 up and down, up and down. From here up is what we call sigma a. The bottom part here is sigma min, and the top is sigma max. Okay. So I wanted to show you kind of do a practice problem to kind of prepare you for the next problem. Okay. And this is how you draw these oscillating or fluctuating forces. Okay, best of luck.